We're going to get a little bit theoretical today. We're going to talk about some theorems, but don't be dismayed. They're actually pretty easy to understand what they do. Understanding like how they work is not as easy, but anyway, they're pretty easy to understand what happens. So remainder theorem says is the first one, and then factor theorem is the second one. Now the remainder theorem basically says that if I plug in some value c into a polynomial p, right? The value of p of c is also going to be the remainder when I synthetically divide p of x by x minus c, right? So if I take c and I synthetically divide the polynomial, whatever my remainder is going to be the same number as when I evaluated my polynomial at whatever that coordinate was. So that's not going to make any sense until you actually look at this polynomial. So the polynomial is x cubed minus 4x squared minus 7x plus 1. I'm plugging in c is equal to positive 6. So what I'm going to do is I'm going to synthetically divide first. So I bring down 1, I multiply 6, I add it's 2, I multiply it's 12, I add it's 5, I multiply it's 30, and then I get 31 as a remainder. So what I want to figure out is, okay, well, if I had taken this polynomial and plugged in 6, what would have happened? Well, I would have gotten 6 cubed minus 4 times 6 squared minus 7 times 6 plus 1. And that, if you put it into your calculator, you'll actually get 31. So pause the video and plug it into your calculator and see that you get 31. And then cheer, enjoy, because this is just so cool. So anyway, we have this other theorem, which is the factor theorem. And it says that a polynomial has x minus r as a factor, right? It might be x minus 2 or x plus 3 or whatever. It has x minus r as a factor if and only if r is a root of the polynomial. That is, if that value r, when plugged into the equation, makes the whole polynomial equal to 0. That's what that means. So let's suppose I have z plus 2. Okay, I'm going to test if this is a factor. And my p of z, right, my polynomial is z to the 5th plus 2z to the 4th plus z cubed, and then plus 2z squared plus z plus 2. So what I'm going to do is I'm going to just take negative 2, which is my r value. It's whatever makes the factor 0, basically, right? So I'm going to plug in negative 2. And I'm going to figure out if that equals 0. So it's going to be negative 2 to the 5th power plus 2 times negative 2 to the 4th power plus negative 2 to the cubed plus 2 times negative 2 squared and then plus negative 2 plus 2. Okay, so basically I get negative 2 to the 5th power, which is negative 32. And then I get a positive 32 from the next thing. And then I get a negative 8, and then I get a positive 8, and I get a negative 2 and a positive 2. So all of that cancels out, right? And I get 0. So yes, indeed, z plus 2 was a factor, okay? So what I'm going to do is I'm going to combine these two theorems together. And I'm going to ask myself, if I synthetically divide by x minus r, and the remainder is 0, then therefore x minus r is a factor. Because remember that the remainder theorem said that whatever the value of the remainder is when you synthetically divide by something, that's the same as if I plugged it into the polynomial, right? So if I synthetically divide by x minus r and r is 0, right, the remainder is 0, then x minus r is a factor of the polynomial. Okay, so what does that mean? We're going to do an example where we make this happen. So I have this long polynomial, and I'm going to try to figure out if x plus 2 and x minus 3 are factors. In other words, is negative 2 and 3, are they roots? Do they have a remainder of 0? So I set up a synthetic division with all of my coefficients. I bring down the 2, I multiply it's negative 4, I add it's negative 9, I multiply it's 18, I add it's 7, I multiply it's negative 14, I add it's 6, I multiply it's negative 12, and then I get a remainder of 0, which means that negative 2 was a root. Okay, but what I'm going to do now is I'm going to reduce my polynomial because I've divided by x plus 2. I write the reduced form of the polynomial that starts with 2, negative 9, 7, and 6. I don't need to use the first one that's longer, right? I use a simpler one. And when I synthetically divide by 3, I also get a remainder of 0. So now my new polynomial is 2x squared minus 3x minus 2. And I'm going to set this equal to 0 to find the remaining roots. Okay, because I know how to solve a quadratic, because I can factor them, I can use the quadratic equation. I just have many things at my fingertips, right, in order to solve quadratic equations. So then I get two factors, which is 2x plus 1 and x minus 2, which means x is equal to negative 1/2 and 2. And of course, those other two roots also worked.